Okay, we have Unit 1, graph, analyzing the graph. So first of all, X-intercepts means where it touches or crosses the x-axis. So you can see there's 3. 1, 2, 3. And they're not in great spots, so we're going to have to kind of estimate a bit. So this one looks like it's really close to -3, but not quite. So we're going to call that maybe -2.90. This one is also kind of close to -1, but not quite, so maybe -0.80. And this one is 1, 2. It's past 2, not quite at 3, so maybe 2.80. So those are my 3 x-intercepts. My y-intercept is where it crosses the y-axis, which is right here, and that looks like it's not quite at 2, so maybe 0, 1.9. All right, my domain. If this was continuous, which it's not, right, because right now I can say, no, it is not continuous because I can't trace it. If I start tracing with my pencil, I have to pick up my pencil because there's a hole. If it was continuous, I would have all my x values, but I don't. I have a hole right there. So I'm starting from the left, right? To the left of x is -infinity, to the right is +infinity. Same thing with my y, to the bottom is -infinity, and it keeps going up to infinity. So I start my domain from the left, which is -infinity, but I have to stop right here at 1. So this is x equals 1. Because there's a hole, I'm not including it. But then I'm starting right back up again at 1 and going to infinity. Again, if there was no hole, it would just be -infinity to +infinity. My range, as I go up, I see there's a hole here, and that happens when y is 3. However, I do have a value when y is 3, right? I have a value right here. So even though there's a hole there, I have another option for 3. So my range is -infinity to +infinity. Because there is another option here. There's no other option for 1. There's no other x value that is 1. But there is another y value that is 3. All right, we said increasing is uphill, and we always use, right, all of these are going to use x values, and we go from left to right when we talk about uphill, downhill. So left to right. So from left to right, this is downhill. That's decreasing. This is downhill. From left to right, this is uphill, which is increasing. And I don't have any flat part. Constant would be flat. I don't have any. Before you actually write your intervals, it helps put your x values. So I'm going to write all my x values, so I'm going to highlight them too. So x values, I'm going to write them on my graph. So my x value here, right, is -infinity. That's my x value. It's going toward the left. And then we want all the bottoms and tops of hills. So this is a bottom of a hill, which is at 1, 2, so -2. That's the x value here. This is the top of a hill. That's my x value. And then my x value here is infinity, because it's going to the right forever. So these are my x values at the ends and the bottoms and tops of hills. So now it's really easy to do increasing, because I can see my values are right there highlighted. It is increasing from -2 to 1. Same thing with my decreasing. If I've got them written and highlighted, it is decreasing from -infinity, stops at -2, and then it's right here from 1 to infinity. Okay, going to focus for me? Maybe not. All right, lastly, end behavior. End behavior, this is saying as x goes to the left, what happens to y? As x goes to the right, what happens to y? It wants to know, is y going up or down? So as x goes to the left, as we go to the left, right, this is what's happening. It's following this as I go to the left, which means it is going up, which means it's going toward infinity. As I go to the right for x, my y is going down, which means it is going to -infinity.